Find the area of the shaded region. So what we're going to have to do here is, well, first of all, let's find the area of this circle, which you'll see is a semicircle. It's half of a circle because that's a diameter there. And so that's going to be, well, 180 degrees over the 360 degrees, which, surprise, surprise, is a half. That makes sense because it's a half a circle. So we're going to take 1/2 of the area of the circle if it was a full circle. If this circle were a full circle, like that, the area would be pi times radius, which is 4 squared, which is 16 pi. So we're going to take half of 16 pi, which is 8 pi, which is nice. So that means that we get, that's going to be 8 pi feet squared is that part of our figure that's a circle. Now, what about this triangle? Because the problem is that I don't know what the height is. Like I know what this is, but I don't have an altitude here or an altitude here to use either of those as a base. So we got to use the Pythagorean theorem to find this unknown distance here. That is 8 squared, this leg, plus x squared, this unknown leg, is equal to 17 squared. And 8 squared is 64 plus x squared. Phew, another sneeze. We are on 2 sneezes, ladies and gentlemen. Can we break the record? Can we beat the number of sneezes that Mr. P had? I'm just kidding. I think that is a new record. I think this is we're setting the record. We're breaking records here, folks. We're going to subtract 64 from both sides. Yeah, sorry, I'm doing this up in Idaho, visiting my parents, and I think I'm allergic to something up here because I have been sneezing like bazoomni. Take the square root of both sides, you get plus or minus 15. Forget the negative because it's a distance, so that's a 15-foot leg there. And that looks like 16 foot, so let's get rid of that. 15 foot is what I mean to say. Great. Now we can find the area of that triangle by doing half times base times height, or half times base times, it doesn't matter. So that's going to be 1/2 times the base, which I'm putting at 8, times the height, which is 15. Which, let's see here, 0.5 times 8 times 15 is 60 feet squared. Which means that the area of that triangle is 60 feet squared. And then we're going to add the 8 pi. That is the exact area. As for the approximate, I'm going to go ahead and do 60 plus 8 times pi, which is about 85.133 feet squared. And there it is. Okay, so for this guy, honestly, it looks like this has less to do with sectors and more to do with just finding the area of a circle and taking it out. So if you take the area of the big circle and take away the area of the little circle, like you're making a really flat donut, then we're going to be in good shape. So we're going to do area equals pi times the radius of the big one, which is 17 squared. 17 squared is 289 millimeters. Oh, pi millimeters squared. Excuse me. Look at that. Pi millimeters squared. And the area of the little one is pi times its radius, which it's telling me is 3 millimeters squared, which is 9 pi millimeters squared. So to get the area of the whole thing, you just subtract those. And 289 pi minus 9 pi's is 280 pi's. That's the exact area, which again, if you're trying to tell someone the area of your donuts in an advertisement, nobody's going to, well, okay, I would buy it if you claimed that your donuts had 8 pi millimeters squared more donut than your competitors, but maybe I'm alone on that. So if we do 280 times pi, you get 879.646. So 879.646 millimeters squared. And there you have it. Formula for sector area. Another way of looking at it. The area of a circle is A equals pi r squared. The area of 1/4 of the circle is 1/4 pi r squared. The area of half the circle is 1/2 pi r squared. And the area of any fraction of a circle is simply theta over 360. That is the portion of our circle, of our 360 degrees that we're taking out, times the area of the whole thing. So there it is, folks. Sector area. I hope you learned a bunch. If you have any questions, send a message to your instructor. Hey, if you sneeze later today, think of me. This is Mr. P signing off, and I hope you have a wonderful rest of your day.